Today we are going to learn about a new technique for image enhancement that is known as histogram. So histogram performs in a spatial domain, and in that we are going to learn about histogram equalization and histogram matching. So what is histogram? Histogram of an image is a plot of the numbers of occurrence of gray levels in the image against the gray level values. The histogram provides a convenient summary of the intensity in an image but is unable to convey any information regarding spatial relationship between the pixels. So, as you can see in this figure, this image have an intensity values that varies from 0 to 5. So we need a 3-bit to represent this images whose intensity values can vary from 0 to 7. Now for a histogram, we can see that the number of times 0 occurs in this image is 5. So on the y-axis we are going to plot how many times the number 0 is occurred in this image. So in that case 5. Now intensity 1 is occurring 5 and 6 times. So on the y-axis it is 6. Similarly for 2, 3, 4, 5, 6 and 7. As you can see here that there is no 3 present in this image. So number of occurrence of 3 in an image is 0. So this plot is a histogram plot. So the histogram provides more insight about image contrast and brightness. So histogram H of Rk is equal to N of K, where Rk is the kth intensity values and Nk is the number of pixels in the image with intensity Rk. In the case of normalized histogram, we have to divide this Nk by total number of pixels. If an image is of size of m cross n, so for normalized histogram, we have to divide Nk divided by m into n. Now, as you can see in this figure, this is a low contrast image, or all the intensity values of this image lies between 120 to 210. So it does not use the complete dynamic range. So the intensity, so that the contrast of image is poor or low. So what occurs low contrast? It is because of poor lighting conditions or excessive lighting condition, small dynamic range of the imaging sensor. So as you can see, the same image that have 4 different contrasts. Now you have to match the histogram corresponding to that input image. So as you can see here, this is a poor contrast image. So the histogram of a dark image will be clustered towards the low level of the gray level. So all the intensity values are clustered towards the low level of the gray level. Now second one, the histogram of a bright image will be clustered towards the higher gray levels. So this one is a bright image. So as you can see that all the intensities are clustered towards the higher gray level. For a low contrast image, the histogram will not be spread equally. That in the histogram will be narrowed. This one is a low contrast image. So intensity is not distributed throughout the dynamic spectrum. So it is more or less not equally spread throughout the spectrum. So contrast is poor. Now if we spread the intensity values throughout the spectrum, then it has a high contrast. So for a high contrast image, the histogram will have equal spread in the gray level. Now, as you can see in this figure, this image has a best contrast. So if you have an image of poor contrast, then you want to convert that images into a high contrast image. For that purpose, we are going to learn about histogram equalization. So the idea is to spread out the histogram so that it makes full use of the dynamic range of the image. For example, if an image is very dark, most of the intensities might lie in the range of 0 to 50. It means they are more or less clustered towards the dark region. By spreading out the intensity values, we can make full use of the available intensities and make darker parts of an image easier to understand. So histogram equalization is a process that attempts to spread out the gray levels in an image so that they are evenly distributed across their range. Histogram equalization reassign the brightness value of a pixel based on the image histogram. So histogram equalization is a technique for adjusting image intensities to enhance contrast. It provides a pleasing result across a wider range of images. So definition of components. Histogram equalization is a method of image processing of contrast and adjustment using the image histogram. Equalization can be used to improve the visual appearance of an image. First, we have to calculate the cumulative distribution function of the image using this formula. So CDF is equal to 255 n of j divided by capital N, where summation varies from j equal to 0 to k. So CDF of k is the cumulative distribution function value of the pixel with value k in the input range, and j is the number of pixels with values j and n. J and n is the total number of pixels. So relabel all the input pixel with corresponding values CDF k. So this slide shows the steps involved for histogram equalization. Find the running sum of histogram value. Then in number step 2, normalize the values of from step 1 by dividing the total number of pixels. In step 3, multiply the values from the step 2 by maximum gray level and round off. Step number 4, map the gray levels to the result from the step 3 using one-to-one correspondence. For example, this one is an input image, which is a poor contrast image. So as you can see, the maximum value is 5. So you need a minimum 3 bit to represent it. And the gray values will vary from 0 to 7. Now step number 1. So first we have to for a histogram of an image. So gray level varies from 0 to 7. And number of pixels that represent 0 in an original image is 0. There is a no 1, no 2. 3 is number of times that 3 occurs in the image is 6. Number of times 4 occurs in that image is 14. Number of times 5 occurs in the input image is 5. And number of times 6 occurs is 0. And number of times 7 occurs is also 0. So first in the step 1, computing the running sum of the histogram values. So this third row represents the running sum of the histogram values. Since there is a no zeros, so this one is 0. Running sum is 0. No 1, so again running sum is 0. No 2 is not present there, so again running sum is 0. 3 is present there and 6 number of times. So running sum is 0 plus 0 plus 0 plus 6 is 6. Now 4 is occurred in 14 times in that image. So running sum is 0 plus 0 plus 0 plus 6 is 20 plus 14 is equal to 20. Now 5 comes out to be 5 times. So 20 plus 5 is 25. 6 comes out to be 0. So 0 plus 25 is 25. Now 7 again 0. So 25 plus 25, 0 is 25. Now step number 2. Divide the running sum of the histogram values by the number of pixels. So this, since the original image is of size of 5 cross 5, so running sum divided by total number of pixel is 0 by 25. This one is again 0 by 25, 0 by 25, 6 by 25, 20 by 25, 25 by 25, again 25 by 25, and then 25 by 25. Now in step number 3, multiply the values from the step number 2 by maximum gray level and round off. Maximum gray level is 7. So we are going to multiply this one by 7 and take the value to the nearest integer. So 0 by 25 into 7 is 0. So these three values are 0. Now 6 by 25 into 7 is 42 divided by 25, which comes out to be 2, since we are rounding it off. Now 20 into 7 divided by 25 is 6. 25 by 25 into 7 is 7, again 7 and again 7. Now this one is the original gray level that is in the input image. So 0 is 0, 1, 2, 3, 4, 5, 6, 7. Now after histogram equalized, 0 comes out to be 0 times. 1 is also 0, number of occurrence of 2 is 0, number of occurrence of 3 is 2. So 2. Number of 4 occurred after histogram equalization is 6. 5 is equal to 7. Number of times 6 occurred after histogram equalization is 7. Number of times 7 occurred in an image after equalization is 7. So this one is an input image, and after histogram equalization this one is an output image. So you can see in this example that this one is a poor contrast image in which most of the pixel values are accumulated towards the darker side. Now after histogram equalization, there is an equal spread of intensities. So the output image contrast has been improved. Now this one is another example where the input size of image is 8 cross 8 and the intensity values varies from 0 to 255. So for equalization, we have to count how many times 52 comes into this image. So we are going to put the count here, and the maximum value in the image is 154. So we are going to fill the count how many times that intensity values occurred in an input image. So after filling all these values, we are going to take a running sum. So before that, we have plotted the histogram. As you can see, there is a poor distribution of intensity image across the dynamic spectrum. So now we are going to calculate the running sum. So 52 comes out to be 1 time. 55 comes out to be 3 times. So 3 plus 1 is 4. Now 58 comes out to be 2 times. So 2 plus 4 is 6. Similarly, we are going to calculate the cumulative distribution function or running sum. Now, if we plot this cumulative distribution function, you can find out that it is spread throughout the spectrum. If we are going to normalize it, then we have to divide by number of pixel, which is 8 cross 8 is an input image. So total number of pixel is 64. Now, as you can see in this figure, in the original image or an input image, the 78 value is going to be replaced by 183. How? 78, the cumulative sum of this one is 46 and the maximum intensity is 255. So 255 into this cumulative sum or running sum into 46, divided by total number of pixels. Then we are going to take a round off of that one. So it comes out to be 83. Similarly, if we perform the histogram equalization throughout the image, then we are going to get a better contrast image. So this one is an input image before histogram equalization, and this one is an output image after histogram equalization. These are the various examples. As you can see that most of the pixels in the input image are accumulated toward the darker side of intensities. So after histogram equalization, much more finer details can be seen as the contrast of image is improved. This one is another example, or same example with histogram plots. As you can see, all the intensities values lies in the range of 100 to 200. Where after histogram equalization, the intensity values is spread throughout the spectrum. So that output image has better signal to noise ratio or have a better contrast. Similarly, this histogram equalization technique can also be used in medical imaging. As you can see in the original image, there is a poor contrast image. Most of the pixel intensities are concentration less than 100, and after histogram equalization, the intensity spread out throughout the spectrum, so better contrast image. Then this one is another example where intensity is spread after, when the intensity is spread out throughout the spectrum after histogram equalization, the quality of the image has been improved. So these are some references. Thank you.